Srini, don't forget to start recording.
Hi everybody, good morning. Today webinar we will be discussing about large file uploads leveraging Azure Storage APIs. Thanks for joining. We planned this webinar in such a way that we will be sharing the technology details about this feature. If you have any doubts, you can put that in the webinar chat window, and we will answer them as and when we receive them or at the end of the webinar. So to begin with, today's agenda, we want to cover a brief introduction to the presenters, myself and my colleague Saif, and we want to touch base on the requirements for large file upload, and then the proposed solution to address this requirement. What are the benefits of this approach? And we are open to take question and answers, and we briefly touch upon our SpadeWorks introduction at the fag end of this webinar. So to begin, myself Srini Pule, I am leading Azure and mobile practices at SpadeWorks. I have around 15 plus years of experience in IT industry in various capacities, from developer to lead to architect to leading the practices. I have experience in enterprise solutions in various technologies, .NET, Microsoft, Azure, Java, and Unix systems. So I welcome my colleague Saif to introduce. Saif.
Thank you, Srini. Hello everyone, my name is Saif Mandle. I'm an architect in SpadeWorks, a solution architect, and lately concentrating more on Azure projects, designing, development, architecting, that kind of stuff. I am a total of around 14 years of experience in software industry, all throughout in .NET technologies, in Microsoft technologies. Experience-wise, I'm an ex-Microsoft consultant, a dev lead over there, and prior to that, I was in Wipro as well. And it's been past couple of years in Azure, and so far the journey has been good. Back to you, Sri.
Thanks, Saif. So now let us move to this large file upload requirement. While working with our customers to develop various Azure solutions, we came across this interesting scenario where they need to upload large files, typically of GBs, to Azure-based web applications. So they have this web application hosted on Azure, and the need is to upload huge files. The other typical requirement is that they would like to use the web browsers rather than a thick client to be installed on the client machine. So they don't want a thick client to be used as a mechanism to upload these files. The other requirement looks like this feature should be supported on various internet speeds, whether it is kbps or mbps or gbps type of speeds. The file upload feature should be working smooth. And last but not the least, users should have seamless experience without any session expiries on their browsers because of whatever be the reason. So with this type of constraints or with this type of requirements, we got to work on a solution that addresses this requirement. So we considered various options to drive out this solution, and we finalized on a solution which addresses not only these points but gives additional benefits, which we will walk through in this webinar. So I am handing over to my colleague to walk through the options and the solution in detail. Saif, over to you.
Thank you, Srinivas. Just let me know once my screen is visible to you all.
Yeah.
Okay.
Go ahead, sir.
Okay, is it visible?
Yep.
Okay. So essentially what are we talking here is from a website, from a web application, we want to upload some files. And the business user says, whenever we get back to them, what would be the size of the file? How large would the file be? And the question came back to us, does that really matter? It can be a 10 KB file, or it can be a 10 MB file, or it can be a 100 MB file. Now the reasons why we kept going back to them, asking them the limits, is because there were some technical limits. Initially, going by the conventional way, we went ahead using the HTML file upload control, either in web forms or MVCs. But then there is a limitation. There's something called as a max request length, which is say by default 4 MB or whatever, right? So what it basically means is you cannot upload a file more than 4 MB. Is it configurable? Yes. Can you change it? Yes. Can you increase it? Yes. Question is how much, right? Because for a business user, they come back saying that, hey, 1 GB, 10 GB, would you make that kind of a configuration on your web server? The answer is no, right? So there are other factors also. There are some other configurable parameters also, something called as a maximum execution time, which is again how much is the execution time per request. Is that configurable? Yes. Can it be increased? Yes, again. But again, the question is how much are you going to increase? Here, from a requirement standpoint, there is no upper limit. I mean, the user is actually saying that I should be able to upload, if I want to, even a 5 GB of a file. The question is, where do you use it? Suppose, some files are like CAD/CAM design files or a model portfolio files. So they are pretty big, they are pretty large, and your website needs to support it. The question is, what do you do with it? How do you support it? How do you handle such kind of a scenario where it seems so that there are going to be technical limits that are going to be met? You can go back to your business users and tell them that there has to be some upper limit, but then questions would be asked, are you not going to handle it? Aren't you good enough to handle it? And that's when we start, scratching our brains. What could be the other alternatives? How do we achieve it? The answer came in way of not sending the whole file in a stream at one go, but rather splitting the big file into blocks, into chunks of, say 500 KB. So if you have 1 MB file, example, you don't send the whole 1 MB file to your web server. You split it into 2 blocks of 500 KB, send it in 2 separate requests over to your web server, and then you merge the 2 blocks, compiling it back into one single file, right? With this, what happens is you start addressing the maximum limit of a file. It now really doesn't matter that if your file is of 10 GB also. All would then happen is your number of blocks increases and you keep sending the blocks of 500 KB one after another. So the technical limits of ASP.NET and IIS are easily addressed. However, there is, which is what I'm talking about, is option 2. However, there is some technical challenges to, implementing such solution. If you go on net, there are few examples on MSDN itself as to how they have done it. The whole workflow is pretty complicated, since first you need to give an intimation as to what is the actual file size, how many blocks would be sent. Then on the server side, you need to capture each and every block, make sure that all the blocks right from start to end are captured properly, and then you need to merge it, and then you need to handle the retry scenarios in case if any one block fails to come properly or is resent twice and stuff like that. It makes your life a bit complicated for development as well as for its maintenance, right? Besides, then what are you going to do is eventually the file which you want to save, you have to save it on a blob storage. You cannot save it on a on your web server's physical disk. The reason why I say you cannot save it is because this is a cloud environment, this is an Azure environment. The moment you put it on a physical disk, remember your VM is, susceptible to transient faults and recycling of your VMs. And if that happens, you lose all your file data. So there is no way you can save it permanently on your physical disk. You have to save it on a blob. So with chunking that is sent on the web server, you first save all the chunks on the physical web server, then you merge it. The things further gets complicated when you have multi web environment, a web farm where you have multiple web roles, multiple web servers. Your one chunks comes to one server, the other chunks comes to some other server, and then how do you fuse it? How do you mix it to achieve your scalability, right? So all these are the complications that come up in a multi-farm scenario. What is the third option is what I was saying here of sending chunks of files onto the web server and then the web server merging it into one file. This capability is already been provided by Azure storage, blob storages through REST-based APIs. There are some REST APIs, something like put blob and put blob, blob and blob list, which can be leveraged to send chunks of data onto the Azure blob directly, and then the Azure servers will automatically fuse the different chunks and merge it into one file the moment you send another request. The problem with that is this is good enough if your client is a thick client, say a Windows client or a console client. The problem happens is if you are trying to make these calls from a web client, which is a JavaScript client, you run into CORS issues, because the URL to which you are trying to send the chunks is different from the website to which you belong, and Chrome or Firefox or IE will not allow you to do that, right? Besides, when you have to do it, Azure blobs will not just allow you to send the files or any data, but the security mechanism is you need to append the URL with a shared access key. That makes the whole solution a bit insecure because you are exposing your shared access key to the other part of the world, and if it is used by someone else also, there is no way you can control it. Apart from that, since you are communicating with some other server and you are not communicating with your server, there are chances that the session may time out. So though there seems to be a technically feasible solution, implementation wise it seems to be difficult to achieve it. How do you give this capability on a website that a user can upload, say, a 10 GB file, hypothetically speaking, right? So because in our case, for my clients, that's what they said, that yes, my file can be actually It's not 1 GB, it can be 150 megs or 200 megs, or it can be 20 megs, and our solution should be able to support that. A lot of brainstorming, lot of thinking on it, and we came down to this final solution. Was there any better solution? I believe so. We came up with a pretty good solution, which is what we proposed, which we call it as a hybrid solution. What we are saying here is, let's take the best of both the worlds. The Azure servers, let them, take the responsibility of getting the different chunks, merging the chunks, and compiling it to one single file. Our web servers, let's give them the responsibility of collecting the different chunks from the client and forwarding it to Azure server. So essentially what I'm saying here is, as a part of the solution, split your large file into smaller files or smaller chunks of say 500 KB on the client side. Then send these chunks to our web server, your own web server. Configure this web server in such a way so that this web server then forwards the same request to the Azure web servers without itself taking the responsibility of merging the chunks. Right? Best of both the worlds. The advantages that you get is, since the client is not directly interacting with the Azure servers, the shared access signature or the shared access keys need not be distributed to the client. This can be appended on your web server itself when you are going to connect to the Azure servers. The second advantage of it is, since the chunks of data is continuously coming from the client to your own web server, there is no question of session timeout. Then, of course, since you are giving all the chunks to Azure servers, and that's where the merging is happening, you don't need to write the complicated logic of merging a file, right? And what essentially I'm trying to say is, you are going to expose absolutely the same REST APIs that the Azure blobs support. So these REST APIs are well documented, universal. So knowledge transfer in that terms is covered. Besides that, since you are just forwarding the data from your web server to Azure blobs and you are not storing it temporarily on web servers, that saving of data at two places temporarily also is avoided. How do we achieve this? We achieve this using ARR. The first feature that I talked about, that make your web server get the chunks of the file and then forward it to the Azure web server, can be achieved using ARR. ARR is, in its full form, is Application Request Routing module, which is an additional module to your IIS that you need to install. We covered ARR and its configuration in our previous webinar, the recording of which can be available in the link provided to get the details of it. So the pictorial representation of what I was just talking about is, on the client side, say you have a source file, which is a big file, right? On the client side, you split this file into different blocks of smaller sizes and then send one block at a time over to your web server, where the ARR is as well installed as well, and this web server with ARR installation is configured to then forward the request of such file submissions to Azure blob. So essentially what comes out from your client side to your server, web server, is the bytes of your file block plus the block ID. So when you are sending 2 blocks or 3 blocks, right, every block you will identify it with the block ID. This is the same API that is which is a put block blob method supported by the Azure blob. Next, what we do on the web server is, along with the two parameters, which is the actual bytes and the block ID, we append the shared access signature to it. So, because this is what is required by the Azure servers. But see, the beauty of it is the SAS need not be given to the client. Instead, it can be appended at the server side. Makes your whole architecture that much more secure. And then the same blob is then forwarded to Azure blob. The Azure blob receives the different blocks which are sent by the client side. Then finally the Azure blob receives the put block list request, which contains all the block IDs of the different blocks. This is the comment. This is the commit command, which then tells the Azure servers that okay, all these different blocks now needs to be merged as one single file. Moving on to next slide. Now, in a nutshell, this slide in a nutshell covered how the functionality or how the implementation is going to be. Further down, we are going to discuss the details of it. So, the primary functionality of your web server would be first to get the blocks and the data and then forward it to the Azure servers. How do you achieve it? Using ARRs, right? It's an additional module, as I had already said. In this screenshot, you can see how after installation of the module, it looks like in your IIS, and you would need some URL rewriting rules for ARR to work. How would that work is, here is an example of the rules that which I'm given here. So the URL that would be coming from the client side onto your web server would have a key, something like say storage or block. In this case, it's storage. So the moment or blob, it starts with blob. This rule says that this rule qualifies it. So what it does is then it takes the request and it forwards it to your blob.core.windows.net server, which is your Azure server, or the Azure, which is where the Azure REST APIs are hosted. The R1 is the rule parameter where the container name is specified, and where the storage name is specified, and R2 is the container name that is specified. And if you further see, is where SI is the signature name and SIG is the actual signature that is being appended to the request. Now, that is to take care of the server side. The previous slide was taking care of the server side. Now here, what I'm trying to explain is how do you split a file, a big file, into smaller chunks. If it is a non-HTML compliant browser, then the slicing feature, for slicing feature to achieve, you need to use either Silverlight or Flash. But if you have an HTML5 compliant browser, then you can use the file APIs and the slice method, as I have demonstrated here. All you need to do is first get a reference to the file upload control, right? And in that, then you need to call the slice method. In that slice method, all you need to do is specify the beginning and the ending, size, and the file would be sliced into that much value. This is how the whole operation works out. That on the client side, you split your file into different blocks, and then you send these blocks calling the put block method, wherein you say the block name, the block ID, and the block bits. And once you have transferred, or once you have sent all the blocks, finally you send a commit command by calling the put block list method, in which you give the block name plus the different block IDs. This is what is then forwarded later to the Azure servers, where the Azure server now knows that, okay, this is the commit command for me, and I can now merge these blocks into one single file. Here is the rule that we had already discussed that takes care of forwarding it to the blob. Okay, time for demo. So I have uploaded a small demo onto the Azure server, which uses ARR. So it is an extension of the last webinar's demo, where I have now given this additional functionality of file upload. Here what I have done is I have used the same concepts of splitting the file, right, and this file is getting uploaded over to here. I have an Azure blob container, and in that I have a container which is file upload container. Now through this demo, we will now upload a couple of files over to where are sorry about that, I'm trying to find out where are the pictures. Sample pictures. Oops. Let's try it on Chrome. I'm pretty sure I have tested this. Maybe it's not HTML5 compiler. We need to use an HTML5 compliant browser. Okay, so here, as you can see, I have selected the two files. Now the two files are getting uploaded, parallelly. The chunks are being sent, as and how the chunks are, each chunk is successfully sent, the progress bar is uploaded. And if you want to verify whether the two files were sent here, it was this container. See, the two files that I had uploaded are uploaded to Azure blob. To show you the code, this was my solution, right? And the first thing that is noteworthy is the configuration of the rules. The ARR rules that forwards the request to the Azure servers. So here the incoming request, if it starts with blob, then whatever is further ahead of it is then forwarded to the blob.co.windows.net server, which is your Azure servers that host the REST-based APIs, right? And this is where I am appending the shared access signature along with its key. Next, we have written up a file, a jQuery plugin, which is responsive useful for actually taking up the file, splitting it into small chunks and sending those chunks. So if you could see here, the send file method over here, the send file method over here of the jQuery plugin, this is something which uses the slice method to chunk the files, and then after slicing or after getting each slice, it sends the block to the Azure server, or rather to our server, with the command as block with a unique block ID, which I'm always appending over to it. SAS, if you see ahead on the top, I have just kept it as null. This is how I am sending the different blocks through Ajax request being sent to our web server. From there it is getting forwarded to the Azure web servers, and then finally to commit the block list, we are then calling the block list REST API, and here in the XML that is sent, all the different block IDs are appended. With this, yeah, we have pretty much achieved what we wanted. I mean, we can actually upload as big file as we want without any problem. The usage scenarios of this kind of an implementation is, suppose like in our case it was more of a document management system, but you can also have a media file-based website where you allow the users to upload their videos. Now these videos can vary from 1 MB to almost 100 MBs or GBs, as you know about it. Or maybe a designing site where people are uploading a CAD/CAM file or PSD files, which can be pretty large. That's where this kind of file, chunking of file upload, chunking of files to upload it to Azure blob storage would be helpful. That's it from me for now. Back to you, Srini.
Thank you, Saif.
Yeah. Do I need to make you the presenter again? Okay. Yeah. Srinivas?
So we are open to questions. So if you have any questions, welcome. You can put those questions in the question panel of the webinar. So while you typing the questions, I also want to take a few minutes to introduce SpadeWorks to you all. SpadeWorks is a company located in Pune, specializing in Microsoft technologies and of course Android. So mainly into software development and product solution development, and we also focus on cloud and mobile application development. SpadeWorks is one of the emerging companies in India. NASCOM is the software company's body in India. So it awarded consecutively for 2 years as top 50 emerging companies. Another key differentiator for SpadeWorks is its UCSC methodology, user-centered software engineering methodology, where the solutions are conceptualized thought through from a end user perspective, thus giving a rich user experiences. And Spadeworks has executed and delivered various projects successfully to customers located in USA, Canada, UK, and Europe, Netherlands, of course Australia and Singapore as well. Spadeworks has presence in USA, UK, and Singapore, and main delivery office is located in Pune, India. So the technology focus, as mentioned, it is Windows Azure, Windows Phone, and SharePoint. SharePoint is one of the key offerings, and from mobile perspective, we focus on iOS and Android. And from a service perspective, cloud and SaaS enablement is one of the key focus area for us. Enterprise mobility, and we also focus on product engineering and application development. And support and enhancement is another service offering where we can provide L2, L3 type of engineering support to existing products and solutions. That's all pretty much for this webinar. Thanks for joining, and if you like to contact us, please visit our website www.spadeworks.com and drop in your feedback and inputs. Thanks a lot.
Thank you, Shane.